Welcome students, myself Rahul Kotkar. In this video, we have to discuss about the chapter Mechanical Properties of Fluid. In the previous lectures, we studied about angle of contact, shape of meniscus. So in this video, we are going to discuss the phenomenon related to the angle of contact, that is factors affecting the angle of contact. So first factor that we have to discuss here, the nature of the liquid and solid in contact. The meaning of the sentence here, simply which type of liquid and solid are kept in a contact that will decides the angle of contact. Okay, means for example, let me consider the pure water is poured on the surface of glass, clean glass. So that will be having angle of contact say as to 0. Understood? Okay. The value of angle of contact for a pure water and glass surface is 0 degree. But as you change it as a impure water, either you change it oil and a glass, okay, so the value of angle of contacts are going to be decreased or going to be changing. Okay, in short, what we can say, this value should be depends upon the type of liquid and solid or nature of liquid and the solid in contact. Second thing, the impurity. What about the impurity? So impurities present in the liquid change the angle of contact. Okay, just I use example to you. Okay, what is that? That example having a simple thing, pure liquid means water, pure water is in contact with the solid surface say as to glass. Now if you add some salt to this pure water, so what happens? It will becomes impure, and as it becomes impure, its angle of contact get changes. In this manner, the impurities added to the liquid changes the angle of contact. Next is your temperature of the liquid. So what about the temperature? The temperature change produces the change in angle of contact in the following manner. Any increase in temperature of liquid decreases its angle of contact. Means in any liquid, if you are increases its temperature, the angle of contact decreases. Okay, remember, increase in temperature produces the decrease in angle of contact. But for a given liquid and solid pair, the angle of contact is constant at a given temperature. Means remember, for a given particular solid liquid pair, if you consider glass and water, for that particular pair, the angle of contact should be the constant at a given temperature. Say as to temperature is 20 degrees Celsius, for that the angle of contact is this for this particular pair of liquid and solid. Okay. The medium above the free surface of liquid. Okay. Next factor is what? That is a medium above the free surface of liquid. Means the liquid and solid in a contact. Suppose you put the glass surface over which you pour the liquid say as to water, and above which type of medium is there? Is the air medium? Is the glass medium? Is any other medium say as to liquid, okay, gas, etc., etc., whatever it may be, the different types of medium present above the surface of solid liquid, okay, will decide the angle of contact also. So in this manner, these are about your factor affecting the angle of contact. Now the next is the question in your book, can you tell how does a waterproofing agent works? So what is the waterproofing agent? Waterproofing agent or waterproofing is the process of making an object waterproof or water resistance. Means in short, okay, if suppose you want to not wet the given substance, okay, or object, Okay, means you pour the water on it, then but it becomes the waterproof. Okay, you want to be a waterproof substance, so you will be doing waterproofing. Okay, then this waterproofing agent, okay, what is the function of this waterproofing agent? It just increases the surface tension and angle of contact. Okay, means what happens here, as you pour the water on it, when the water comes in contact with the substance or the object which is waterproofed, okay, so what happens in that case, the angle of contact or the surface tension between them increases, and so cannot be wet the solid completely. You can see the case that we studied about the liquid in contact with the solid in case of mercury and a glass. Okay, what happens? The mercury will not completely pour or completely wet the solid surface. So that is the thing here we observe. So they can be used in case of kitchen, bathroom, roof, okay, and in case of paints also. Waterproofing paints are also there. So in this manner there is the waterproofing agent works. Okay, in short what you can say, it is useful for resist the water with the flower. Okay, next is your effect of impurity and temperature on surface tension. So as just we discussed, effect of impurity. Okay, so here we have to go through the details. So first thing, effect of impurities, in which we have to be given here, when a soluble substance such as common salt, say as to sodium chloride, is dissolved in water, the surface tension of water increases. Okay, it's a very simple phenomenon you observe in your home. Okay, when you add a salt to the common salt, means what? Your edible salt. Okay, so that is added to the your water. So at that time what happens? Its surface tension increases. Okay, its surface tension increases. Remember, in case of for a completely soluble impurity, which impurity type is this? Completely soluble impurity, say as to salt, sugar. In all these cases, what you can say, surface tension increases. Okay, and that's the reason if you buy a new cloth, cotton cloth from the shop, so the particular shop owner, okay, suggests you to wash the cloth with a salty water and with a cold water also. Okay, they will not suggest us to use the detergent water, either they will not suggest us to wash them in a hot water. Okay, why they suggest us? Because the surface tension increases. Okay, next is your, when sparingly soluble substance such as phenol or detergent is mixed with water, surface tension of water decreases. Okay, what is a sparingly soluble? Means those who are not completely soluble. Okay, they will produce the color like a milkish color when they dissolve inside the in a liquid. Okay, so in that case we consider them as a phenol or detergent. You can see the color of that particular liquid mixture. Okay, what you observe, somewhat milkish. So that is known as a sparingly soluble. Okay, in case of the sparingly soluble impurities, the surface tension always decreases. Okay, so that's why we are using the detergent or soaps for washing the clothes, because to remove the dirt from the clothes, we are using the detergent powders or the soaps. When you rub the particular dirty area, so what happens? The liquid, means water, which are using for washing the clothes, that will move inside the threads of that particular cloth, and that will be get clean easily. And that's why we are using a detergent, and it is a sparingly soluble impurity, and using it, what happens? Surface tension decreases. Next is your, when insoluble impurity is added into the water. What is the insoluble impurity? The insoluble impurity is what? That is like dust. Okay? Surface tension also decreases. Okay, so remember, simple example, if you consider that when you put a glass on a table for a longer time, okay, which is filled with the water, okay, for a longer time, you will observe there some particle of dust settle down on the surface of waters. Okay, so what happens? That is the dust particles. And when these foreign particles or dust particles are present on the surface of liquid, say as to water, so what you can say here, because of these dust particles, okay, the surface tension decreases, because these foreign particles will disturb the liquid surface which is under the tension, or which is like an elastic membrane, okay, which is get disturbed by this particular dust particles. Okay, so in this manner, these are some factors, okay, which affect the surface tension. Okay, this is about effect of impurities. Now one more thing is there, addition of impurity to any liquid, the cohesive force of liquid decreases, and which affect the angle of contact and hence the shape of meniscus. Okay, means simple phenomenon is given here, why this occurs so. Okay, means when you add the impurity, so the value of cohesive force decreases, means cohesive force between the liquid molecules decreases, and as it decreases, so what happens? The angle of contact, hence the shape of meniscus get affected. Okay, so next point is your effect of temperature, okay, on surface tension. So in most of the liquids, as temperature increases, surface tension decreases. It's a common for all. It's common for all. For all the liquids, what you observe? Temperature increases, surface tension decreases. Okay, and that's why the reason is there. I just explained this example recently. New cotton fabric should be washed in the cold water, because cold water have a high surface tension. If you increase the water of this, temperature of this water, so what happens? Surface tension decreases and the liquid moves very inside the threads of the cloth and can remove the color. Okay. Then hot water is used to remove the tough strands on the fabric because of its lower surface tension. We are using the hot water. Okay, everyone know that in our home. Okay, there is a regular phenomenon is there, dirty clothes. Okay, those who are having a much more strengths. Okay, means tough strengths are there. So at that time, our mom using liquid detergents, either they are using the detergent or the soap, and they will be pour it inside the hot water for a longer time. Okay, why the reason is there? What's the reason is there? Simple, there should be the surface tension of liquid, that is a water used to wash these clothes, should be decreases. Okay, means in short, because of the hot water, surface tension decreases and it will be clean the clothes easily. Okay, but in case of molten copper or molten cadmium, okay, we just studied what? In most liquids, temperature increases, surface tension decreases, except these two liquids, molten copper and molten cadmium, are the two liquids for which surface tension increases with increase in temperature. Remember, these are having a controversy. Okay, what is that? Liquid having a increase in temperature surface tension decreases, but these two liquids are there which having increase in temperature, also increase in surface tension. Then surface tension of liquid becomes zero at critical temperature. Okay, or you may call what is the critical temperature. Means in this manner you can define the critical temperature in case of surface tension also. The temperature of the liquid at which the surface tension of a given liquid becomes equals to zero. Okay, that is called critical temperature. Either you can say simply surface tension of liquid becomes zero at critical temperature. Okay, hope so you understood each and every concept. Next is your excess pressure across the free surface of liquid. Okay, every molecule on a liquid surface experiences forces due to surface tension which are tangential to the liquid surface at rest. Okay, in case of phenomenon related to the molecular forces or molecular behavior, okay, we studied there the molecule which are present on the surface of liquid experiences the force due to surface tension, and this force is always tangential to the liquid surface which is at rest. Okay, that's we know here. In case of definition of surface tension that we also studied there, this is the imaginary line drawn and these forces are tangential to this imaginary line drawn. Means what? There is a tangential force to the liquid surface at rest. This is a tangential force. Okay. Then shape of the liquid surface decides the direction of the resultant force of surface tension acting on a molecule on the liquid surface. Here, what is the meaning of this? What is the shape of the liquid form? Okay, depending on the shape of the liquid surface, means in short, you can call shape of the meniscus. Okay, will decide the direction of resultant force. Means in short, what is the meaning here? If suppose this is your concave surface, means what? The direction of resultant force due to this forces due to the surface tension is like this. Okay, means if you have a concave meniscus, at that time what you can say? It will have the resultant force due to the surface tension is in the upward direction. Okay, in other case what you can say, if suppose you consider the convex meniscus, this is the direction of force due to the surface tension and the result of both is directed in the downward direction. Okay, so what is the sentence here? Shape of the meniscus of liquid surface, okay, decides the direction of the resultant force of surface tension acting on the molecule of the liquid surface. This force also decides the pressure at a point just below the surface of liquid. Means using this resultant force, what you can decide? You can also decide the pressure at point just below the surface of liquid. Actually, all these things we have to verify in our next points or next subtopics. Okay, so next topic is your. Let here we consider that Fa, that is a downward force due to the atmospheric pressure. Okay, just imagine that the liquid due to the air column or atmosphere present around it, the force acting at any point, okay, is in a downward direction, okay, and that is your Fa. Let here we consider that Ft be the resultant force due to surface tension. In diagram, you can see here the resultant force acting on a liquid. Okay, so Next, that is molecule A is just above the molecule A is just above and the molecule B is just below, that is inside the liquid. As you observe this diagram, you can observe here, where is the molecule A is present just above the surface of liquid, and where is the molecule B is present just below the surface of liquid, that is inside the liquid. Then level difference between A and B is almost zero. Means as you observe this diagram, what you observe here, there is no level difference. Okay, the liquid levels are very closest to each other. Means these points are not far away from each other. Okay, and so there is no question about the pressure difference. Means what? The pressure difference is also zero. Okay, means point A and point B both have a same difference because they are very closely spaced to each other, even they are in a different they are present in a different medium. Okay, means A is present in the air medium and B is present in the liquid medium, but they are very closely situated to each other, and that's why there is no pressure difference. Then the pressure at point A is the atmospheric pressure, that is P. Okay, what is the pressure present at point A? Which is nothing but the pressure due to the atmosphere. Okay, then again we consider, okay, these are the things which are related to this conceptually to this diagram. Now actually what is the plane liquid surface? Okay, means how much the pressure exerted on the plane liquid surface, that here we have to study. Okay, you observe that this diagram in which you can see here, for a plane free surface of the liquid, the resultant force due to the surface tension, that is Ft, acting along the molecule at point B is 0. You can observe here at the liquid surface. Okay, you can observe there is the direction of your forces acting, okay, due to the surface tension, and that's why both are equal and opposite to each other, and so they cancel, and what happens? The force due to the surface tension at point B is equals to 0. So therefore the force Fa, means atmospheric pressure force, is itself decides the pressure and the, okay, what is the pressure at point A or at point B? That will be decided by what? Only the atmospheric pressure. Okay, but A and B are very closely spaced to each other and they have a same pressure. Means what? Pressure at point A and pressure at point B are the same, as well as what we can say, the inside pressure and outside pressure is also the same. Inside means what? Inside the liquid, and outside the liquid both pressures are same. Next point that here we have to discuss, convex liquid surface. As you observe the diagram again, what you can say here, for a liquid having surface is upper convex. Okay, means which is looking convex when you see from the top or the above. Okay, so at that time what we can say here, the molecule A is just above and the molecule B is just below it. Means what? Inside the liquid. Same situation is there. Again the molecule A is present above the liquid surface and molecule B is present below the liquid surface, that is inside the liquid. Now in this case what happens? Ft be the force, okay, that is the resultant force due to the surface tension, okay, on molecule B, and it's vertically downwards. Remember, in each and every case we are talking about the resultant force due to surface tension, and which is always acting on molecule B because it is present inside the liquid. Okay, so Ft will be acting in a vertically downward direction. What about the molecule A? Okay, the molecule A In case of that, the Fa be the downward force due to the atmospheric pressure. Fa be the downward force due to the atmospheric pressure, and this is nothing but your force due to the atmospheric pressure which is acting in a downward direction. And the result of both means both forces are along the same direction. So as they are along the same direction, so what happens? Both forces get adds, and what happens? Develops a larger pressure at point B. Okay, which is this point B, which is present inside the liquid and on the concave side of the meniscus. Means what we can say here, the result of this, the pressure acting on the concave side should be greater as compared to the pressure acting on convex side. Okay, in similar manner, the pressure present inside the liquid, okay, is equals to the is greater as compared to the pressure outside the liquid. Okay, this in and out are related to the liquid. Okay, so it's a simple phenomenon. All the things are similar here, but what we are referring? We are just referring the force due to the surface tension acting on a liquid surface, okay, and second thing is the atmospheric pressure, and according to that we are deciding the where is the pressure is greater and where is the pressure is smaller. Okay, and that's why some sentence which are beginning of this topics are given to you that are important. Okay, there is no need to remember them. Okay, but these are related here in this manner. Okay, the next point, that is your concave meniscus, concave liquid surface. Again we are going to consider the same liquid surface. Okay, means for a liquid having a surface as upper concave. Means when you are looking from the top or from above, you will observe that it have a concave meniscus. Okay, so molecule A is present just above the molecule B. In short, what I have to say, the molecule A is present just above the liquid surface and the molecule B is present just below the liquid surface. Okay, that is inside the liquid. Okay, means the surface is there, liquid surface is there, above which the molecule A and below which the molecule B, as similar to the previous two topics. Again in this case what we can say, Ft be the resultant force due to the surface tension on the molecule at B. Okay, means at point B the force due to the surface tension acting is vertically upward. Okay, and Fa be the downward force due to the atmospheric pressure. Fa is what? Downward force due to the atmospheric pressure. As you observe, Ft is acting in the vertically upward and Fa is acting in a vertically downward. So what we say, both forces act in opposite direction. Both forces acts in the opposite direction, and you observe according to the vector, Fa should be the less and Ft should be the greater, and the result of this, what we can say, that develops the less pressure at point B. Okay, Fa is less and Ft is greater. So what is the direction of resultant force? In the upward direction. Means what? The less pressure will be created at position at position B, okay, which is present inside the liquid and on the convex side of the meniscus. Means the greater pressure is acting along the concave side as compared to the convex side. Okay, so the relation of the pressure is given to you. The pressure along the concave side is greater as compared to the pressure along the convex side. Okay, in other way, what you can say, outside pressure should be greater than inside pressure. But remember, don't refer like outside and inside everywhere. depending on the side, say as meniscus, say as to concave, convex, okay, your out and in should be changes. Because in the previous case, what we seen there, the pressure on the concave side is less as compared to the convex side in previous case. Pressure on the concave side is greater, okay, and convex side is less. Here, pressure on the outside should be greater and inside is smaller. But in the previous case, what is the thing there? Pressure on the inside is greater compared to outside. So remember, depending upon the shape of meniscus, this in and out will be changes. Okay, otherwise you can refer this simple. A table is given to you. This table gives you the idea about this, okay, about the comparison related to these three meniscus. Okay, and you can see here the resultant force due to the surface tension. Okay, for a plane meniscus it is a 0, and for both it is a vertically downward. For convex and for a concave it is a vertically upward. Okay, direction of resultant force acting. Okay, atmospheric pressure is acting vertically downward in all cases. Pressure A is same. Okay, means in between the A and B we are comparing there. So pressure at A and pressure at B is same. But in case of convex it is a less and greater. Okay, towards the convex side it is a less, and towards the concave side it is a larger. Okay, similarly here also what we see, in case of concave meniscus it is larger along the concave side and smaller along the convex side. So you can see here in all the cases related to the concave and convex meniscus, the pressure acting on concave side is always greater, and in case of plane meniscus the pressure along the both side, means at the above and below or inside and outside, remains the same. Okay, these are the last row shows you the comparison, and which is very important. So friends, now here we'll stop our lecture. Okay, if you have any doubt, so you can ask me in the comment section. Thank you for watching the video.